They are extracted from plant rather than any petroleum product. And when plants are produced for when plants are planted for producing biodiesels, they have the capacity to absorb CO2 during photosynthesis. For this reason, biodiesel has the only potential to absorb CO2 and greenhouse gases before it is being actually used. Slide please. For production of biodiesel, we have identified tetrahydrococcus as the it will be as shown in the picture, and it's a wild plant and it can grow in any atmospheric and climatic conditions. It doesn't need any particular type of soil composition or soil type, and it's most suitable for production of biodiesel as non-edible oil. There are also further other options of making biodiesel such as cottonseed oil and sunflower oil, but they are edible oils. But we can use tetrahydrococcus for producing biodiesel, and it's most flourished in India. This picture shows the tetraphoid extraction. First, the tetraphoid plant is planted, and the oil seeds are harvested from the plant, and the harvested seeds are ground in oil mills, and the extract is filtrated with the pure tetraphoid oil. Next slide, please. Tetraphoid oil has some superior qualities when compared to diesel. It has a high CTN number of 51 when compared to diesel of only 45, and it has a high flash point of diesel, which makes us easier to save and transport during transportations. And the tetraphoid has up to 10% of its chemical composition, and it makes us easier for combustion. And tetraphoid doesn't have any sulfur at all, and there's no SOx emissions when using tetraphoid. Like this. This table shows the comparison of properties between the diesel oil, non-esterified tetraphoid, and esterified tetraphoid. You can see the reduction in the viscosity of tetraphoid before and after the esterification process. After the esterification process, the viscosity goes to 5.51. Before it is up to a height of 50. That's why we can't use tetraphoid directly as a fuel in diesel engine. So we are going for esterification process. The flash point of esterified tetraphoid is 1.5. Whereas diesel is only 61. Slide please. This is the production process of the biodiesel. First, the tetraphoid is extracted from the seeds, and then it is esterified, and then it is subjected to esterification. Then it is distilled for its purity from glycerin. Then the tetraphoid ester got from the product is blended with the diesel for preferred ratio and is taken for testing in an ICG. Next slide, please. These are the chemical transformations we undergo. First, the tetraphoid is mixed with ethanol and allowed to react for 8 hours at a temperature of about 70 to 100 degrees Celsius in the presence of NaOH, that's sodium hydroxide, and we will get a mixture of tetraphoid methyl ester and glycerin. This mixture can be separated into tetraphoid methyl ester and glycerin using gravity separations. Thus, obtained pure tetraphoid methyl ester is mixed with diesel in the ratio of 20:80 and taken for our experimental testing. Okay, please. This is the production plant we use for producing tetraphoid methyl ester. First, tetraphoid or pure tetraphoid is charged from reservoir to the esterification chamber number 2, numbered as number 2. Then the transesterification is done in the chamber 3, and 4, 5, and 6 are the distillation chambers where gravity separation is done to separate tetraphoid methyl ester and glycerin. Next slide, please. These are some samples of the oil. This sample 1 shows the pure tetraphoid. The sample 2 shows the glycerin. The sample 3 shows the oil that is the mixture taken half an hour after the reaction has started. That is the esterification reaction has started. And the number 4 sample shows the mixture of tetraphoid methyl ester and glycerin layers. Number 5 shows the gravity separated one tetraphoid methyl ester and glycerin. The sixth sample shows the pure tetraphoid methyl ester and distilled water. The practical and experimental view of the tetraphoid will be continued by my friend Karthik.
Let us move to the paper. After the extraction process, we can directly use our tetraphoid methyl ester in our existing diesel engine without any modification. But we got under some few precautions because a tetraphoid methyl ester having a solvent property that may release deposit accumulated in the tanks and pipes from the previous usage of diesel fuel. So that initially we need to clean our fuel passages and overall our fuel injectors and newly provide fuel filters. And another important property of tetraphoid is tetraphoid methyl ester react with the rubber. So we prefer non-rubber as oil sealing. Non-rubbers like PVC, fluoroelastomer and stainless steel. Next slide please. Now this is our experimental setup. We tested tetraphoid methyl ester in the college laboratory. The picture shows that this is a Texwell engine to which the fuel supply system is connected, and the alternator is directly coupled with the Texwell engine, and loading is given to the alternator's electrical loading unit. Next slide please. Regarding the specification of our engine and alternator, our engine is named as Texwell engine, having a number of cylinders is 1, and number of strokes per cycle is 4 strokes per cycle, and cooling system we use is water cooling system, and speed is 1500 rpm. For alternator, the rating is 4 kilowatt RPM. 4 kilowatt RPM, the voltage is 230 volts, the frequency is 50 Hz, and it also having a speed of 1500 rpm, and the maintained temperature is 30 degrees Celsius. Next slide, please. Coming to test procedure, first we have to start our engine using decompressor lever, and engine is loaded by using electrical loading unit. After attaining steady state condition, we make 3 observations. First, time taken for fire evolution of energy disk, and second, time taken for 10 cc of fuel consumption, and third one is spring balance reading. Similarly, we taken for 1000 watts and 2000 watts of electrical loading. And this is the common procedure we follow for both diesel and jet turbine methyl ester 320 with the same engine condition as we mentioned. And the observation that are rated as follows. Next slide, please. Yeah, this is the observation we got for diesel from the Texwell engine. For electrical loading in 2000 watts, time taken for fuel consumption of 10 cc is 40 seconds, and for time taken for energy meter of fire evolution is 25 seconds. Next slide, please. The observation we have tabulated here is for jet turbine methyl ester. The electrical loading unit of 2000 watts is 2000 watts. The time taken for 10 cc of fuel consumption is 53 seconds for jet turbine methyl ester, and for energy meter is 48 seconds for jet turbine methyl ester. Next slide, please. Using formulas, we calculated the brake thermal efficiency and overall efficiency and generator efficiency for diesel. For 2000 watts, the brake thermal efficiency of engine using diesel is 29.05% and overall efficiency of diesel is 17.97%. Next slide, please. And for jet turbine methyl ester, this is a graph we plotted for brake thermal efficiency. And for 2000 watts, the brake thermal efficiency is 40% for jet turbine methyl ester. Next slide, please. This is the overall efficiency for jet turbine methyl ester and diesel. Jet turbine methyl ester having 19% high when compared to diesel. Next slide, please. Coming to conclusion, jet turbine methyl ester is having a better performance and fewer emission than diesel, and having a percentage increase of brake thermal efficiencies up to 50% and overall efficiencies up to 6.8%. It having a lesser COHC and particulate emission, and cost of a jet turbine is 40 rupees per liter. And the main drawback of jet turbine methyl ester is NOx emission is high, but it can be reduced using selective catalytic converter, and we employ some additives to reduce the NOx emission. Finally, we say that jet turbine methyl ester is the ultimate alternate fuel of India, and it can make us self-sufficient and independent for auto fuel. These are reference we got in that. Thank you for your patience.
Nice presentation. Cultivation of this Jehovah is a major problem.
Yes, sir.
Of course, you are saying that maybe a liter it's 40 rupees. Okay, yes, no problem. But do this.
Sir.
So we can use the waste lands and useless lands for cultivation of jet. That will be effective for production.
All are telling the same one. Nobody uses.
But it cannot be implemented.
It should be implemented by government.
And one more question. Normally they are telling that jetrofoil. What's a jetrofoil and you mentioned that
Jetrofoil is the pure oil got from mills by grinding. Jetrofoil methyl ester is after esterification. When jetrofoil is done esterification.
Normally, vegetable oil is you have to make esterification and then you have to use in it.
But we are coming from the sources. That's why we are mentioning as the jetrofoil and jetrofoil methyl ester.
You have done the experiment in your lab.
Yes, sir.
So the initial cost is very low. So we have to do it and use the stands and guidelines.
What is the estimated cost of 1 liter?
40 volts.
No, the final end user product.
End user, yes. After the certification, we can get.
After all the process is for
Yes.
Can you explain CTN number?
CTN number is the index which refers the fuel quality opposing to NOx. If the higher the CTN number, it will less number of NOx and the combustion of the fuel will be better. It's an index.
You are mentioning whether it's a CTN number high or low.
High.
Then in your